Welcome back to our discussion of solutions for Chapter 13. This is Dr. Rhonda Cofeld for Calhoun Community College. And what I'm going to be discussing in this part are colloids, characteristics of colloidal solutions. You may not realize it, but you've probably seen a lot of colloids. Okay, colloids are just basically you have particles in a solution, but they don't fall out of solution, they're suspended there. Okay, and what you see is cloudy, or you just can't see through it. Examples here that hopefully you can picture this: fog, smoke, paint is a colloid, milk, shaving cream, even clouds are colloids, where you have particles suspended in a solvent. So the defining quality of colloids is that they scatter light. If you shine a light into a colloidal solution, the light will not pass through, or at least a lot of the light won't pass through. That's why they appear cloudy. And so that's also why if you're in a foggy area, you put your low beams on so that you're pointing those beams down towards the road instead of straight in front of you. If you do them straight in front of you, then that light is just going to be scattered and you're not even going to see what's in front of you. And so, and in the lab, the scattering of light has a name. It's called the Tyndall effect, and it's just the effect of scattering that light. If you put light through a clear solution, the light will go through. But if you put it through a colloidal solution, then those particles that are suspended in there actually cause that light to bounce off of them and not pass through that liquid. And so, as you see, you can have various surface areas of these colloids. They get pretty big, and they can interact strongly at the surface with other molecules that are in there, and especially with ions. And so if you've ever swum in a river, okay, and you know sometimes rivers don't look very clean, they look kind of muddy, and that what's happening is they're carrying this suspended silt, and some things will fall out of solution like sand and things like that. But if you have clay bottoms, that the clay molecules will suspend very easily in the water, and it's very hard to get those to come out. They really won't settle out, and so that's really defining of a colloid. And so we're just showing you these charged particles and them repelling, and so you can see with all of this going on, that light would be bouncing off these atoms and molecules, ions, and would not be able to go through. And also that those positively charged particles are going to repel each other and are going to keep that colloid from grabbing hold of the negative components and dropping out of solution. So colloidal solutions can be hydrophobic or hydrophilic. The hydrophilics like water, and so they're polar. And so you have a lot of biological materials such as hemoglobin, as they've got here, that's showing you that it is a colloid, and it is going to be suspended in your blood plasma. Hydrophobic or water-hating colloids are going to be insoluble in water, and they are going to be things that would be suspended in a nonpolar solvent. Mayonnaise, some people love it, some people hate it. It's a hydrophobic colloid. It's vegetable oil and eggs, and it's suspended in water, and they get it to do that by a special way of mixing it. The protein lecithin in the egg yolk itself works as an emulsifying agent. And an emulsifying agent or an emulsifier is something that keeps materials suspended in the fluid and keeps them from settling out. Soap and detergent are also emulsifying agents. A lot of times you have a sodium or a potassium salt of a fatty acid, and fatty acid's basically just a big long chain carbon molecules, and then at the end you've got a positively charged ion connected to it. And so if when you look at it, I've got an example of sodium stearate here, I think. Long molecule, okay? At the very end, though, you have that polar head. And so that allows this, the big hydrophobic tail, to stay suspended in the water enough to float along and move with the water. And so it doesn't separate into an oily phase based on the nonpolar region, because it's got enough of this, and that's what makes it an emulsifier. It can keep things suspended in there. Soaps are a special type of emulsifier. You get large soap molecules, and what they do, so this is a whole bunch of the molecules, and they will orient so that the hydrophilic ends are out. And if you've had biology, this probably looks like a cell membrane. Okay, so you've got the hydrophilic water loving in contact with the water, and then the hydrophobic part is inside so that it doesn't have to touch the water, okay, because it doesn't want to. This structure is what we call a micelle, and the hydrophilic tails allow it to stay in the solution, but it can surround oily things like dirt and grease and things like that in your water, okay, and that will trap that there and allow that to actually move through the water and eventually like be discharged if you're in a washing machine or something like that. Hard water, and if you live in around where I am in Alabama, we have a county called Limestone County, okay, so that's got a lot of this stuff, okay, and hard water contains either iron, calcium, magnesium ions. These are going to be from calcium carbonate and other mineral deposits that are found in the soil, and they will stay suspended in the water as well, because when you put soap with these things, they will cause them to float. And if you look at your bathtub and you have a ring in it, okay, when you have been washing and everything to get the oil off your body, and you're using soap, this scum, they call it, will form, okay, and it's the anions from the soap reacting with the cations from your hard water. And it's pretty disgusting, actually. So calcium with the soap anion giving you this insoluble material that will just sit on your tub, and then you have to scrub and get it off. Synthetic detergents were designed to substitute for soap, but they don't precipitate in hard water. So they emulsify, but they don't leave that solid, that insoluble solid after. And so the synthetic soaps work quite a bit. One of the main types of detergents that we use in those synthetic detergents are called alkyl benzene sulfonates. And they are very, very good detergents and are used quite a bit. A lot of stuff these days, they talk about not having any type of sulfur or sulfate groups in them because of the environment. So this is how you clean your clothes. Okay, you use this little thing. It's going to grab a hold of, it's going to stay in the water, and then your non-polar end is going to grab onto those greasy, dirty things that are in your clothes. And so then that keeps it in the water so that when you discharge it, it goes out with the water and doesn't stay on your clothes.